All right, now we're recording. So today we're going to talk about variables, a way to store stuff for later, and just asking questions of the stuff that exists inside your program. Like, is this true about this thing? We took so much care to learn about trues and falses. We better use it somewhere. So yeah, we're going to first learn about variables, which are just boxes. And you give a name to those boxes like X, and then you put something in there like 42. And now you can say X, and it will always give you back 42 whenever you reference it. So it's just a nice way of giving a short name to something potentially very complicated. That's what a variable is good for, right, in math. So we're going to use those in programming too. So I think that'll be the first thing that we talk about today. All right. So a variable, it is just a box. All right. It is something that exists in memory that can be used to store information for later. All right, so for example, I can make a variable called X, and that makes a box. I can make a variable called input, and that makes another box. And I can put stuff in there. I can put 1,234 into that one, 42 into that one. Variables are just boxes, so let me just write that. A var is just a box for computer scientists, at least. Just a box. And it makes your life easier because you don't have to remember like 1, 2, 3, 4 ever again. You can just say X. You don't have to remember what the user typed. You can just say input. Whatever they gave me, I will use that in some bigger expression. Like I can use the X now in my program to like compute X plus 1. Maybe I needed that number for some reason. Or maybe the user gives me a number and my job is to double it. So I will take that input variable and compute input times 2. It's just storing something for later, and that's quite useful, I would say. We haven't made any variables yet in our programs in Scratch, so it is time, all right? So I think the simplest program that I can think of that uses a variable is let's change that hello world program to say hello and then the name of the person who's running the program. So we're going to ask the user, you are the user, right, if you're running your own program. We're going to ask the user for their name first. Then we'll be able to type it, and then we'll get that, and it will be able to go into a variable, and then we can reference that variable later to say hello, whatever your name is, all right? So that's going to be the idea. That's where we're going. So to get there, I need to introduce a couple ideas. So we're going to be getting information from the user. They're going to be typing something, and it's going to go into a default variable called answer in Scratch. Like, we'll ask the user for their name, and so it will hold their name, whatever it is. And when the user types those characters, it is we're getting textual data, right? We're getting the keys that the user typed. We're getting text data from the user, and in computer science, somebody decided to give it a weird name, and so text data to us as computer scientists is called a string. Think of it like a string of letters on like a friendship bracelet or something. That's what it means to be text data. I will call that a string, right? It's just a bunch of characters, and there is a difference between the string 1, 2, 3, like the characters 1, then 2, then 3 in that order, versus the number 123, right? And the difference is the types. So the variables that you have in Scratch, it's not very apparent. It will get more apparent when we go to Python. But every variable has a type, and those types tell you what you can do to those things. So, for example, if I had the number, like 123, oops, I can spell number. If I had the number 123, then I could like add it to other stuff. I could multiply it with other stuff, right? That's what you can do with numbers. But with strings, that's impossible. You can't do number stuff with strings. You can print out a string back to the user. You can give them that text back, spit it back out. You can compute bigger strings from smaller strings. That process is called joining them. But the type dictates what you get to do. So there's a difference between the characters 1, then 2, then 3 versus the number 123. Right? There's a huge difference. And it probably won't make a lot of sense until I show you the errors that you get when you try to use one for like arithmetic when you shouldn't have. Right? So that is the start of it all, and that's where we're going. Are we ready for a hello, your name here program? Okay, let's see here. So yeah, let's get as far as we can before I have to talk about string stuff. So here's my program. I want it to start when the green flag gets clicked. So I'll zoom in there so you can see it. When the green flag gets clicked, let us ask the user for their name. And there's a block for that. Probably in looks. There's an ask block, and oh, thank you. Yeah, it's been a semester. I have to learn where it is again. There it is. It's called the ask block. Ask what's your name and wait. And if we run it, if we click the green flag, it does exactly what you would think it does. This is the Scratch Cat's program, and he's the one asking them, right? So ask what is your name and wait, and so I can type my name, hit enter, hit this check mark, and what just happened is the answer got saved into a special variable right below the answer block. This is a variable. See how it's a little circle? It's not like something you can compute with. It's something that can be part of other blocks, other computation blocks. And so the program's over. I type my name, but this variable got changed. All right, there was a box. There was a box called answer, and it just got Lawton inside of it. I promise. If you click the variable, it will show you what's there, and it's a little small, but assuming you're trying it too, you can see that it got whatever you put there. So if I say like 123, that's my name, then the answer variable now holds 123. Okay? It's getting whatever we type. So ask what's your name and wait, and then whatever we type goes into this special variable called answer. Does that make sense? That's where it all lives. And so I can get it, whatever the user typed. It's different every time we run the program, of course. I can always get it back by saying answer. I can have as many answers as I need in my program in different places, and they will all hold the same thing that I just typed. All right? Until you have a new ask block. That'll overwrite answer. Okay? So we need to respond, hello, comma, space, name, exclamation point. And so answer just holds the name, right? We want to make the string, we want to say something, right? We want to say, looks is where you say stuff. We want to say not just hello, we want to say hello, your name, right? So we need to build up that larger string using smaller pieces. And it's down here in the operators section. Do you see how I could say not hello, but I could say answer for 2 seconds? I could put a variable up in there because it would fit. So what's your name, Lawton? And now he just says my name back to me. But I could have him say hello, comma, space, my name, by joining the answer string to another one. All right? So this is the join block here. It takes 2 things and it adds them together. So apple plus banana joined together is apple banana, yeah? And so if I want to say hello Lawton, I could do it like this, join. But it's really just going to add one right next to the other. So if I want a space in between, I have to put a space after this hello. Hello, or comma space, for example. And now if I click on it, it's computing hello, comma space, Lawton. But I am not done. I don't want an exclamation point at the end of that. So here's one way to do it. There's a couple ways to do it, but it's going to be another join, right? I've built up this string with stuff in the front, and I want to put something at the end of that. So I better join whatever I had with an exclamation point at the end of that. And so you can kind of just read it in order. It's going to take hello, then answer, then exclamation point. But it's like building this first, and then putting exclamation point at the end. If you click that, it gives me what I want. All right? So that's joining, and you might need multiple join pieces. Any questions about that? I'm building up a bigger string using smaller strings with the join block. And so now I can tell the Scratch Cat to say whatever this computes for 2 seconds. And so click the green flag. What's your name? Hello, my name. For 2 seconds. If I rerun it, I can, of course, type something else. Like, my name is 123. And then it'll say, hello, 123, exclamation point. It's different every time we run the program. That's really cool, right? Now it's interactive. We're slowly beginning to make things that could eventually become games, right? That's what interaction means. We need that. So, yeah, that's our first program. Hello, comma, space, name, exclamation point. Any questions about that? There's the full program. All right, so let me save this so I can give it to you later. And let's keep on trucking. All right, something slightly more complicated. let us compute, the absolute value of the user's input. So in addition to taking words, we can take numbers, and Scratch understands that what we type is a number when it's just a bunch of digits. And so let's ask the user for a number, and so in answer, we'll get some number like negative 42, and let's output the absolute value of that number. Okay, it's just a simple math program. Let's do that. So let's start all over. And instead of starting when the green flag gets clicked, let's start when the sprite gets clicked. So when I click the Scratch Cat, everything below this event will run. That's a new thing. Why not? All right, so let's ask the user for a number this time. What's your name? No. Enter a number, please. Enter a number, maybe with a colon, and wait. All right, so now in the answer variable, after we type that, we're going to get something. For example, if I type negative 42 and I'm clicking the green flag and nothing's happening, that's because the event is when the sprite gets clicked. So I got to click the Scratch Cat to start the program this time. So negative 42, now answer holds negative 42. Let's use that and compute the absolute value. So say for 2 seconds the absolute value. And so that is taking answer, and I think there's an operator for that. There it is, it's abs. There's a bunch of mathematical operators. You could do abs, you got a couple others that I can explain, square root, sine, cosine, tangent, inverse ones of those, logarithms, it's all there if you need it. So look into those if you'd like, but here's the absolute value. So if answer holds negative 42, the absolute value of answer holds 42. It gives back 42. So that's my answer. All right, so it's just simple math. That works too. And I got to click the sprite now for this one to work. Enter number negative 42, and it says 42. If I enter positive 42, of course it doesn't change it, because the absolute value of a positive number is itself. Okay, so that is my next silly example. Are we good with that one? Very similar, just a different, it's math this time. Math instead of string stuff. I honestly wonder what would happen if I enter a number and say my name. Yeah, I guess it gives a nice default value, but it was confused, right? You should have typed a number. Abs only works on numbers. All right, so that's absolute value. Save that. Okay, so we've been using a variable that was made for us. It was made for us by Scratch. It's the answer variable. It's linked to the ask block. Let's make our own variables. There's a section down here for that. See the orange section, variables? Let's make our own. So here's how you make a custom variable. Let's make a variable that increases whenever we press the spacebar. So every time I press the spacebar, it's going to make a number go up inside of some variable. Let's call it x. So maybe x starts out at 44 or 42, whatever. Doesn't really matter. And once I press the spacebar, it's going to increment that variable's value. So it was 43, it'll become... Sorry, it was 42, it'll become 43. And if I press it again, it was 43, now it'll become 44. Won't that be nice? So let's do that. All right, so let me walk you through it. So this is kind of the code that we're gonna make. But first, let's create that variable. So let's go down to the variables section. Let me delete the old program. And by default, every time you start a Scratch program, it makes a variable for you called my variable. You can right-click and rename it, or you can make your own new variable if you'd like. Give it whatever name you want. So either way, let's make an x variable. Pick your poison. I'll just rename this one to x. But this is a variable that I can now use. And I can change it. It's by default, it's 0. I can change it. I can set it to something. I can change it by something. So if I chain these blocks in a cool way, like if I started at 42, set x to 42. If I run that block by clicking it, now x holds 42. All right? And I can click the change block to run that. Change x by 1. It was 42. Now it's 43. Change x by 1. Now it's 44. Isn't that cool? Let's do that. So let's see. Yeah, I think that is a good example. So let's have this all happen. Maybe I don't like the way that I was planning. Let's have it this way. Let's make 2 ways of running this program. So when the green flag gets clicked, how about we start x at some starting value, like 42, so we can always start over. And then every time we press the space key, how about have that change x by some amount? You can also have it count down if you change it by -1. It just adds that into the variable. So that's kind of cool. And if you go to the variables section, if you see there's this little checkbox. If you check it, it will display the value of the variable there. Always. There's also a show variable block that I think would do the same thing. Checks it for you, I guess. So you could just automatically check it, but here's a silly program. Let me click the green flag, and sorry it's so small for you. I think hopefully you're following along. You can see that the code is large at least. But up here in the top left, it's showing you the current value of the x variable. And so when I click the green flag, it always resets to 42, because that's what that code does. And then when I press the space key, you can change that to whatever you'd like. When I press the space key, it's going to run this code, and that will change x by 1. 42, 43, 44, 45. Isn't that cool? If I hold it in, it goes very fast. But you have a little counting program. If I click the green flag, it starts all over again at 42. Let's see. So that's one program. Does that make enough sense to us? So I wanted to show you that before I showed you what I was doing in the slides. So that's a cool little program. But let's go back to what I did in these slides. I think the program was this: set x to 42, change x, show it, change x by 1, show x again. All right. So when I press the space key, x is going to get set to 42. It will display that number. Then I'm going to change x by 1, making it 43, and show that number. So here I am pressing the space key. Boop. If I press it again, it's just, all I see is 43. It is becoming 42, but all I'm seeing right now is 43. Isn't that weird? So this is where I tell you that your computers are really, really fast. All right, our computers are so fast that essentially running this show variable block right before this change and this other show variable, like all of these take like nanoseconds to run. And so the display can't even reset itself in time to show you the value of x sitting at the original starting value. I guess it was 44 in my example. You'll never see 44 because it will change it so quickly to 45. Does that make sense? So if you wanted to see the 44 for a second in the top left, you have to make the program wait because it's just too fast for us. All right? So you can say wait 1 second or 2, and that will allow some time in between the showing and the changing. Yeah. So I'll press the space key again. Now you see for a split second in the top left of the program window. There it is, 44 for a second. Okay. So yeah, our programs are so fast. Sometimes you output something, but you don't see it because it's just over in the blink of an eye. It continues so quickly. Super duper fast, kind of instantaneous. All right? Any questions about that? It's the longest program we've wrote today. Let's make some longer ones. All right, if we're all right with that, let's see, where do I want to go next? Plenty of time. So, yeah, I think what I want to tell you right now is our programs are cool. Like, we've written some cool stuff, but they could be cooler. All of our programs right now, they're just a bunch of blocks in order, right? You got your event beginning block. It looks like this with a little spot for its first block. And it's like, do thing A, then do thing B, then do thing C, then do thing D, right? That's our program so far. And that's just, if I change that to like a flowcharty kind of form, it's first do A, then do B, then do C, then do D. They're just straight lines. Our programs are just straight lines. That's not super exciting. Wouldn't it be cooler if we could do the following? I'll use rainbow for effect. So there's one thing that we haven't been able to do yet that we can. It's called branching. Wouldn't this be nice if we have A and then potentially go over here and do B, or potentially go over here and do C, depending on some condition? And then maybe we come back and we do D at the end. That'd be cool. We don't have that yet. And then also, there's something called a loop that we also still don't have, even if we had branches. Like that is do A, then do B, and then come back to A. Maybe do this until the end of time. We don't have that ability yet either. That would make for another exciting program. And that combination would make for an even better one, right? So that's where we're going in the class. I think we're going to go to branches today, but not, I guess I could do simple loops as well. So a branch is just where your code splits, can do one thing or another. And then a loop is where your code comes back around on itself and repeats things. So you don't have to write the same blocks a million times. If you just want to keep doing the same thing and have to copy and paste, you just use a looping block, all right? So honestly, it's a bit easier to teach you loops. So here's a loops example. We are going to make a funny program where the scratch cat spins. And so let me make a blank program. And for fun, I don't know, let's use another event. When the up arrow is pressed, this will run the program below. We're going to have the scratch cat ask, how fast should I spin? And we're going to make him spin super fast. And here's how you make him spin, right? You have this turn block. Make him turn right or left, but here's me clicking the block a few times at a certain frequency. If you do that, right, he turns 15 degrees each time. If I change this 15 to 30, and I click at the same frequency, he spins faster, right? So essentially, we're going to ask the user for a number, and then use that number as the degrees for this block. All right, so if you tell him to spin 15 fast, then he'll spin a little slowly. And then if you tell him to spin like 30 fast, he'll spin faster. All right, and then how do you make him spin a lot? Well, you can put like 15 of these turn blocks one after the other, or you could make it repeat itself. Here's how you do that. All right, so here is it's in control, it's a repeat block. And it looks a little interesting, right? It's got, it is a block itself, but it can put stuff inside of it. Isn't that cool? So I don't want to turn 30 degrees, I want to turn answer degrees. So it's essentially going to click this block for us 10 times. I can repeat this 10 times, I can repeat it 50 times, however much I want. And it's going to make the scratch cat turn answer degrees. It's going to click this a bunch of times fast, right? And so if answer is a larger number, he'll spin faster. Does that make any sense? That's kind of cool. So here is that running. How fast should I spin? And then you give a number. And it's the up arrow that's going to start this program. So how fast should I spin? 15 fast, whatever units that is in. 15 degrees per second, and do that 10 times. So I click go or hit enter. There he goes. It just clicked that block really fast for me, and it ran it 10 times. So I didn't have to copy and paste it. Isn't that cool? And so that was 15 speed. No, it's up arrow, sorry. 15 speed spins him that much. If I say 30 speed, it's going to turn 30 degrees each time, and it's going to be 10 rounds of that clicked very fast for us by Scratch. Woo! So now he's probably very dizzy, right? And so you can make this very large, 60, and now he's very unhappy, most likely, okay? You can make it very slow, like turn 5 at a time. Whee! And so that changes how fast he spins because this is animation. It's just going to do this a bunch of times, 10 times fast. And if we change how much he spins each, essentially, frame of the animation, then we make him look like he's spinning faster. All right, are there any questions about that? It's a fun little example. That's a loop. We're repeating this code 10 times. All right, so the number 10 you can change. That's the number of times you'd like to repeat the inner code. Number of times repeat the inner code. And here is the inner code that gets run 10 times. All right, so a larger number, faster spinning. And more rotations, of course, as well. So that's fun to play around with. Are there any questions about that? So that's a simple loop. There are other loop blocks that I'll teach you later. But you can make some interesting animations with this so far. So I'll save that so I can give it to you. What next? Okay, yeah, I'm excited for this one. So now let's go to branches. All right, so I gave you a little sneak peek of loops, and let's now go to branches, which is the ability to start at a certain starting point and then branch off and have our code do one thing or another. And the way we determine whether or not we do one thing or another is to ask the question in Scratch, like, I should go this way if something is true. I should go this way if that thing wasn't true. It's going to be a truth kind of question, a yes or no question. Like, if the answer is yes, go left. If the answer is no, go right, kind of thing. All right? And so branching all comes down to the idea of conditions, like conditionally go this way or this way, and there are going to be the answers to questions. Okay, so true and false. We're going to ask a true or false question to Scratch, and if it's true, we'll go down one branch. If it's false, we'll go down a different branch. Okay, so that is the idea. Yeah, so let me just explain that with an example that is not A, B, C, and D. Right, so yeah, we want our programs to do one thing or another, depending on some condition. Maybe the condition is based on the input. Maybe it's based on some random value that we compute in our game that we're making or something. So it looks something like this. Like we ask a if kind of question. If the answer was equal to 42, in that case, if the answer is yes to that, the answer really was 42, do thing A, right? And then if the answer is no, do thing B. That's going to be how we control which branch our program goes down. We have conditions up at the top. So answer equal 42, that's a yes or no question, and that's called a condition. Okay, I hope that makes enough sense. And so you can put as much code over here in the yes part and as much code as you want in the no part. You can go on forever. And you can also make it come back and do the same code at the end. And I'll show you all of that. Right? So you can have many dots down there. That is branching in a nutshell. That's what we're about to do. And so we're going to ask questions to Scratch. It will figure out the answer, if it was yes or if it was no, and then we'll have two options prepared to go down depending on what that answer was. Right? So, yeah, to get there, instead of yes or no, in computer science, of course, we have to make new words for everything. Like instead of text data, we say strings. So instead of yes and no, in computer science, we say true or false. All right? And these are called Boolean values, right? So true or false, bools for short. This is a Boolean value is the answer yes or the answer no, which we are calling true or false, right? So we want to ask questions to Scratch like, is the answer 42? Is the answer less than 0? Is the answer greater than or equal to 7? Stuff like that, all right? And so we'd like to do one thing or another depending on if that question is true or not. So yes, just to spell it out for posterity, yes means true, and no means false. Those are equivalent ideas, right? That is what Scratch cares about. And yeah, let me just clear out the program and show you how to compute Boolean values just very quickly down here in the operators section. Like you have these plus things that do number stuff, you have these random things, and you have these conditions. Look at how instead of these things that are circular, that could be part of something we could print perhaps, something that we join together in a string, look at these. Something greater than something is 55 greater than 50. This one's pointy. That's a different kind of block. We haven't seen that yet. And if I click that, it's going to run it, and the answer is yes, so Scratch computes true. You see that? So that's how that one works. This is a relational block. It's checking is something greater than 50. Is 55 greater than 50? And the answer is yes, so it's saying true. It's doing that computation for me. All right? If I say 49 is 49 greater than 50, then it's going to say false because the answer is no. And so I can condition based on these pointy blocks. That will give me back true or false. That's pretty cool. All right, so with that in mind, I made that very simple absolute value program using the abs block, which just immediately computed the absolute value. But let's come back to that, and let's make that same program without the abs block. All right? So this is what I want you. You're eventually going to do this. I'm going to give you this as a question in a second. But here's the idea. Absolute value without the abs block. So here is, let's say we got a number from the user, right? That's what we did. Like maybe they typed negative 42, and our job is to compute the absolute value of whatever the user typed. Okay? So think about what it means to be the absolute value. Think about some examples. So maybe the user typed negative 42, maybe they typed positive 42, maybe they typed 0. What would you give back in each case, right? If the user typed negative 42, what's the absolute value of that? That's positive 42, right? Positive 42. So there's something there. What's the absolute value of normal 42? That's still just 42. And then like weird things that are close to the edge cases. What's the absolute value of 0? That's just 0. Do you see how, if we were to program this ourselves, we are sometimes changing the answer, the thing on the right side of the arrow, right? For some of them, it's the same value. Like if it's already positive, we're giving back the same thing. But sometimes, and if it's 0, we're still giving back 0. But sometimes if it's negative, right? If we were given a negative value, the result of the absolute value of that negative number is to chop off the negative sign. So we have to change the number. And so that's how you program absolute value. You have to figure out, all right, do I need to change the number? If so, how do I do it? All right? So let me draw the algorithm. I hope you have one in your mind as well. Come on, little button. Okay, so here's the idea. We always have to get the input from the user. That's going to be the start of the program. Like enter the number you want to take the absolute value of. Get that. And then, because they might type a negative number or a positive number or 0, we have two options for the output, right? If we want to give back the absolute value or print it out, either it's negative, if so, we better change the number and chop off the negativity, or it's positive, we don't want to add a negative sign, right? We want to keep it the way it is. So there's the two options. That's the branching. Right? So the question that we have to ask of our number, of our answer, right? The one that determines whether or not we change it or not is that answer negative? Is the number that the user just gave me, is that negative? So check if, or let me write it as a question. Is the input, which is living in the answer variable, of course, less than 0? Question mark. So that is going to drive the rest of our program, because if the answer is true or yes, we have to like multiply it by -1, get rid of the negative sign somehow, because we know it's negative if we're down this side. Or if it's not, then we keep it the same. Okay, so those are our two options. That's how we compute absolute value. So if the number is negative and we go down this side, go down this branch, then how do we make it positive? Well, the easiest way to do that, assuming like we're the ones programming the absolute value block, we don't get to use that anymore. Well, you just multiply it by -1, right? You know it's negative. Get rid of the negative sign by multiplying by -1. Right? Now it's positive. Does that make sense? And then you can print it out. Display it. Put it in another variable. Do whatever you need to do. Whatever is your requirement for the rest of the program. And if it's false, that means it was not negative. So it was like 42 or 0 or 5. In that case, you don't change it. You're just immediately ready to print it out. Right? That's the other case. So false. If it's false, you're immediately ready to display the number without having to change it at all. All right, so those are your two options, and that's how that works. All right, so does this flow chart make sense? That's the program that you would write if you knew how to write it. That would correctly always output the absolute value of a number. So the way you do it, the way you figure out, the way you say in Scratch, I want to do one thing or another, is you use this block here. It's in control again. Underneath repeat, it's called if, then, else. All right, and it's got two little sections. You see that? It's got a little section for one part and another section for another part, and it also has a pointy section, a pointy part up above, where you could put something that gives back true or false inside of it. Okay, so that is the key. So that's the block that we need here. It's going to do one thing or another, and it can potentially, once it's done, do more things underneath it. But you see how it has two options baked into it, right? So this is the if-then-else block. And so let's talk about it. So the very first thing up top is the question we need to ask. Which side do we go down? So this is where the condition goes. Condition goes here. All right. It must eventually become true or false. That's what it means to be a condition, a yes or no answer. Must become true or false. Because that's going to drive which side we go down. We need it to be that. All right. Scratch is nice to you. It forces you to put a pointy thing here, and all that pointy things can possibly give back is true or false. So that's that. And then, so that's the first thing that Scratch is going to do. It's going to ask the question. And then we have two parts. We have this bit, which I'll label 1, and this bit, which I'll label 2. And I think you can imagine what they do, right? So if the condition is true, then we do thing 1. We do all the blocks that you put inside of here. You can put as many as you need. So all this code in here, it'll expand itself as needed, gets executed if the condition is true. Executed if cond is true. All right, if it's true. And I call that the true branch. You'll hear me say that a lot if I haven't said it already. And then the other one is what happens if the condition is false. If the answer is no, executed, we're going to the else part. Executed if cond is false. All right, and so I'll lovingly call that the false branch. I hope that's not too bad. Okay, so the idea is, going back to flowcharty kind of form, the way that the if then else block works is it has your little pointy condition. That's your cond in my nomenclature. Then if it's true, if the answer is true for that condition, it's going to do thing 1. It's going to run all the code there. And then if it's false, it's going to do thing 2. And it'll run all the code there. Does that make enough sense? That's how it's going to do one thing or another and how it's going to branch. All right, so with that in mind, let's see. I'll give you this. Here. It'll be small. And I'll give you this. It will also be very small. Come up to the board if you need to see it better. And now I have a question for you. Whee. So I'd like you to make this program. You can have it when the green flag gets clicked or whatever. Start it however, but get the input from the user. Like here's the little flow chart. Here's the program that you're writing. Get the input from the user and compute absolute value. Compute the absolute value of that input. If it was negative, if it was positive, you got to do 2 different things. You're going to need an if then else. All right, come up here if you'd like to zoom in on that and look at it. But please help each other. I'm going to give you plenty of time. Take quite a few minutes to try this and ask for help. I want you to learn how to use the if then else block yourself, and then I'll give you my my answer after you've had enough time to work on it. But yeah, take the number from the user, print it out. If you get it done early, try putting it into a variable and working with that variable instead of just the like the answer block. Okay. So does the question make enough sense? All right, take quite a while. I'll give you several minutes to give the try to this. See if you can get it. Absolute value of whatever the user types, assuming it's a number. Mm-hmm. Take about another minute, then I'll show you my answer. Alright, did we get it? So, with all that in mind, let's see, what do we need to do? I'll delete this just in case I want to draw something. Here's how I might have done it. I guess we can start the program in the normal way. Get a green flag gets clicked, ask the user enter a number, with a colon or something. And so we want to do one thing or another depending on if that answer is negative, right? If it's less than 0. So we need to make that condition. We need to make that less than 0 condition with the answer variable, because we're comparing that with the less than operation. I guess you could have used greater than if you flipped it around. Is answer less than 0 is the question we'd like to ask. Yeah. If it is, if it's true, then we want to give back the negative version of the output. So we'll just like say it or something. Say not answer for 2 seconds, but answer times -1, right? I'll need a couple of these. So if the number is negative, then I would like to respond with the positive version of it, right? I need to negate it so that I'm actually giving the absolute value back to the user. So answer times -1 for 2 seconds. Otherwise, let me duplicate this. Otherwise, just say answer for 2 seconds, right? So this would be how I write the program. It's the easiest way, I guess. Does it make sense? If the answer is less than 0, then say answer times -1. Because if it was less than 0, it was negative, make it positive. Say it times -1, please. Whatever that answer gives me. And then otherwise, if it wasn't less than 0, if that was a false response, then it must have been 0 or positive. So I don't need to change it. It's already its own absolute value. Okay, so this will work for -42. It gives back 42. This will work for +42 and anything close on the edge like 0. The second it goes negative, though, -1, it goes back. It goes down this branch and computes answer times -1. If answer is -1, that times -1 is +1. Yeah. So that's my program. Any questions about that? Is that what we got? Well, that's what we wanted to get. There's another way that you could do it if you would like. So here's one way. Let's do it with an extra variable, because why not? So we are unfortunately not allowed to change. Like maybe you thought that this little bubble meant change the value of answer. I don't think you're actually allowed to change answer. You're allowed to do stuff like down here. It's like change my variable. I don't think you can select answer. Set answer to 0. No, it doesn't work like that. So it works for your own variables, though. So if I have a variable called x, I can do whatever I want to it. Set it, change it. So let's do the program again this way. Let's have the answer variable, whatever the user typed, and then let's put into the x variable that I just made. Let's shove answer into there, and then I can actually change x. I can multiply it. I can set it to something else. I can actually update the variable to something different, which is a weird thing to do. Like you can't really, in math, variables don't change. But in computer science, they do. So let's do it that way. So enter a number. Let's immediately take that number and put it into x. So set x to whatever the answer that we were given was. Go up here. Set x to answer. Does this make sense? So the second I run this program, where did x go? If I run this program and I type, for example, -42, it's going to take that -42 out of answer, right? Put it into x, and now x also holds -42. And that's useful to me because I can change x. I can do stuff to x, and I can set it to something new. Okay? So that's the idea. So instead of saying stuff inside the if, how about I do it this way? How about if, let's work with x now. If x is less than 0, because it holds whatever answer held, if x is less than 0, make it its own negative. Like get rid of the negative sign by multiplying it by -1. So set x to be, this is weird to think about, set x to be whatever it was times -1. Oops. I promise this works. It's very odd that it works. So let me do this separate for a second just to show you. So, boop. Oh no, sorry. Didn't want to do that. I wanted another set. So that's normal. Keep that. And then I could do, it's this one, right? That's the one that I wanted to show you. So if x is negative 42, setting x to x times negative 1, clicking it, will now change x to be positive 42. Isn't that weird? So it kind of like runs this part over here, computes a new value, and shoves it into x. So if I click it again, now x is negative again. If I click it again, now x is positive again. It's a little weird, but I can change the value. I can update a value of a variable. I'll add a comment. I am allowed to update the value of a variable. That is not called answer, at least. All right? And then, well, maybe the else case doesn't need anything at all, because maybe at the bottom is where I want to say the value. Like, if it's negative, change it. If it's not, don't change it. And then at the very end, after all that has like been dealt with, just say the answer for 2 seconds. Just both of you do that, please. All right, so now I have an empty else. That's interesting. But it's going to work. If I say negative 42, it's going to say back to me positive 42, because if x is less than 0, and it was, it's going to change it to be positive 42. And then this whole thing is done, because it picks one side or the other. And then like the whole if-else block is done, and it's ready for the rest of the code. And it just says x for 2 seconds. If I enter positive 42, it's going to say 42 back, because it's going to like, hey, is this less than 42, or is this less than 0? No, it's not. So it'll run whatever's in the else. There's nothing in the else. And then this whole block, this if-else block is done. It can do whatever's below it. And now it says x for 2 seconds. So this is another way to write the program, and I didn't actually need the else. There's actually a version of this without the else for that reason. There's just an if. If you only want to do something, if a condition is true and just like do nothing if it's false, you only need the if version of this. That's kind of neat. Let me change it over to that. Let me do some surgery here. Do that. Do that. Go away. Do that. Do that. So now something only happens to x when it's negative, which is kind of what absolute value is anyway. Maybe that's cleaner to you. But this is the same thing. Negative 42, positive 42 computes the correct absolute value. Any questions on that? It's just a style kind of thing, I guess. Either way works. But this one involves our own variables and changing them. And that's what I did. We good with that? It's a fun little idea. So if we're all right, let me give you your next programming assignment. And let me save this as well so I can give this to you later. There we go. Let me release it. Programming assignment 1. So first of all, this is going to be due on the 2nd, which is the next week. All right, so next week on the Thursday. So it's not a 2-week exercise, it's just a 1-week exercise. So this is programming assignment 1. And again, if you've programmed before, you're going to have a different assignment. You can talk to me if you want a custom one. But if you have never programmed before, here is your assignment. All right, you are going to teleport the Scratch Cat magically. So, and the program's going to start when the sprite gets clicked. So when the sprite gets clicked, your program should do this. You should make the sprite magically appear in a random place on the screen. So you're going to teleport the Scratch Cat. I wonder which of these blocks could teleport a Scratch Cat to a random place. Maybe this one. So this is the step 1. Make the sprite go somewhere random when you click him. And then, depending on where he went, you can make it be the Scratch Cat, you can make it be whatever sprite you want. I would like you to have that sprite respond and say, I'm above like the middle half of the program or something. I'm in the upper half of this program window. Something like that. I'm above the middle, I'm below the middle. I'll show you what I mean by that. And then if your sprite teleported below the middle of the program window, just say something different so that you're branching. I'm forcing you to use branches, okay? That's the idea. So say something different if you'd like, and you can play a fun sound, but this is kind of what's happening. You are going to click your sprite, and they're going to magically move somewhere in your program window. They're going to teleport. And remember that your sprite always has coordinates to it. There's always a concept of where it is. Like here is its x coordinate and y coordinate down here. You can get at those with, is it sensing? Or is it looks? I'll find it for you. There it is. It's in motion. You can get the current y and x coordinate of your sprite with these variables. Like here's its y position. That's the one you'll need for this. So you're going to check. You're going to click your sprite. It's going to teleport somewhere randomly. And then if your sprite ends up here above the y equals 0 midpoint of the window line, just have them say something to that effect. Like I'm in the top half or something. And then if you click the sprite and he randomly teleports to the bottom half, check that and have him say something to that effect. Like I'm in the bottom half of the window. I'm just forcing you to use branches. That's all. I'm in the bottom half. Just prove to me that you understand branches and you can make one thing or another happen depending on a condition. All right, so you have to use these blocks. You have to use a block that contains the word random, because that's how you teleport. And then you also have to use an if-else block to either say I'm above the midpoint, I'm below the midpoint, whatever you want to call it. And that's the basic requirement. Feel free to get fancy, but here's an example of what should happen. Like, I'm not showing you the code, of course, but you click the sprite and it's like, I'm above the line. You click him again, he teleports randomly. Sorry, it's a little small. He's still above the line. You click him again. The randomness is not in our favor. Now, finally, you click him, he teleports, and he's below the line, and he says that. Okay? That's all. Does that make sense? Teleporting, saying stuff. I'm forcing you to branch and check the y coordinate of your sprite. Okay, so that's your programming assignment if you've never programmed before. This is your first programming class. First of all, before I get to the other group's assignment submission, what I'd like you to do for this assignment onward, if you're having trouble with this one, you can just upload a screenshot again. But for this assignment onward, I would really like you to start uploading videos. That's what I'm going to require next assignment. Not this one, but next one. So try to get it working this time. Please upload a video of your program running. Show me your code. Click it a few times. You don't have to say much. It doesn't need to be very long, just like a minute or something, just so that I can see your code, I can see it run, I can see it do one thing or another. Does that make sense? You can record it however you want. You can use OBS. That's what I'm using. You can use Zoom. I can teach you how. Just record the screen of your computer with your phone if you'd like. Whatever works. But that is the submission that I'd like to see from you from now on for these programming assignments. All right? It proves to me that you understand your program. It's really great. If you can't upload a video this time, like you need to get something, you need to check out a microphone from the library or something, then you can upload a screenshot and just make sure you show me like both options, show me your code, stuff like that. But video recordings will be required for programming assignment 2. Okay, so I'm just warning you now. I will give you credit this time, but start learning how to upload videos and record yourself. That is what I will be requiring next time. Try to do it this time. Any questions about that? So that's going to be your turn-in. And then for those of you who have programmed before, here is your assignment if I have not given you a different one. Read these chapters of the book and do exercise 5. You probably need to install Dr. Racket if you have not already. I think this might be your first graphical assignment. All right. So again, I would like you to record a video if you can and upload it here for credit. If you can't this time, get things working. Come to my office hours. I'll help you. It will be required to upload a video next time. Okay. So those are your 2 assignments, 2 different groups in the class. Any questions about either of them? All right. So this will be due on the 2nd. And I think that is all that I wanted to say. I will stop recording now.